Oh, thank you. Okay, so here we have the robot. Robot has all the requirements that the project needed. It travels over C6s with these like endless screws. And it's rotated. All the body is rotated by this motor. Then this link is rotated by this, and the gripper is rotated by this motor.
Well, I would like to say that we remodel all robots, so we get based on some models, but if you see it closely, you can see that the pieces are unique comparing to the other teams. And also we minimize the stall, so
it would be faster, so it doesn't make so much inertia, and it's easier to control. Then we have the part of the microcontroller. We did our own PCB using a phenolic PCB and jumping of the wires between the GPIO pins and the H-reach and all that kind of stuff are linked over there, and all the signals are delivered to the motors. In the coding part, we have three main programs. The program that goes directly to the ESP32, that it makes forward kinematics, backward kinematics, and then we have the MATLAB, that
which is the computer vision.
The computer vision, yeah. And we have an HMI that was made on mainly on Python, and we try to translate a bit of what we had in the MATLAB code to Python. So we have a trial that we can show you in a bit. And that's mainly what we made here.
Our prototype is actually not running correctly because of the encoders. Yesterday it was working, but today we decided to don't work. But we can force it to make some move.
Yeah. It's only a test mode where we deliver the signal so the stepper motors start moving. So, for example, I choose this motor that is motor 3. I set it to 100 Hertz, and I set the direction and the sorry, it's not turning.
Okay.
So here it's rotating really slowly, but it's rotating. You can see it. I can make it a little bit higher. Just give me a second.
Rodrigo, if you're moving, all the motors are moving, yeah?
No,
No,
you can move all the motors.
Yeah, we can move all the motors.
Please, what we are going to see here is the kinematics, if you can see it.
We can not make it work, but yesterday it was working. I can show you the functions and how they work, but because of the encoders that failed on us early this morning, we cannot achieve the movement with the code we have. That's why we can show you the movement of the motor. So like,
The forward kinematics.
no, actually.
we have the code and also the inverse kinematics. But it's not like runnable at the moment because of the encoders are not working and reading. Yeah.
Okay, so we can see the kinematics or inverse kinematics. We can see the HMI, right?
Yes. Okay, so the HMI is here. Here. One second, I have to close the other serial communication that we have established. Here it is. And here we can see a three-dimensional grid where the Scara Robot will be represented as vectors. Here, for example, if I start moving
The model is Meanwhile, if you want to
Yeah.
fix it, I can show you the
image processing.
image processing. From government side, we try to translate it to Python because these take a lot of resources. So, really want to.
Okay, if working properly, we can go directly to the test, just to the rubric. So, can you take a photo and
Yeah.
after that show me that you are recognizing the color that I decide?
Uh-huh.
And after that, yeah, and we say, okay.
Yeah, now I have here the HMI, if you want to see it. Here,
Okay.
here it is, the representation. Here we have the zeta movement, the first link, the second link, and the rotation on the gripper. Technically, in the gripper, we can see anything because it's a vector, so it doesn't show like the position, but it's rotating, and it sends the signal serially. So with the code that I told you that worked in the morning, we could deliver the angles with this slider, and we only move. And here we have the inverse kinematic part, which we only set points, and we.
But Rodrigo, just a question. This software that I'm seeing here is connected, related with the software in your ESP or not? It means, are you computing the direct and inverse kinematic in the computer?
Yes, I can. I can retrieve the signals from ESP32 and show them here, or I can run them here, and then it will be translated over there.
I want to see from the ESP to the computer because that was a rubric.
Yeah.
I just want to know
Yes,
requirements.
it's showed here, but
And I need to see that.
yes, it does. Give me 1 second because all is failing this morning.
Keep calm. It's not a problem. Keep calm. And everything.
Google.
yellow.
Yellow.
You can see right here, it's not
Here,
it's not printed properly because it's a little bit moved by the enter, but here it received the zero dots. I updated with this because it's not moving. It's only showing the state position.
We go back to the fields. We have to compare actually is we're going to see the entire thing there. Please bring the computer.
okay. So
So, in the moment we're seeing the yellow,
the yellow.
there is one that not.
Because of the
Okay, like that. I want to see the green, if it's possible.
yes.
Green.
Also, we got the position of the encoders. Here we are.
Okay, you have some problems with green.
I think it's because of the.
No, for sure, for sure. Okay, now I want to choose a specific shape. We're going to see the most simple one. I want to choose the circle, the yellow circles here. I want to see it.
Well, I cannot choose a specific form, but
Okay?
what I did, by colors, it serves all the figures, and it tells you the number of objects and which figure is it.
Okay, in this case I want that.
You have to choose a color and it shows you.
Okay, we're going to see the green, the yellow one again.
Or do you want to see it like here?
Okay, and now I want to see. So we have the triangle. Okay, I want triangle. Yeah, yes, you have something here. Okay, well,
Well, I cannot choose the specific one.
so you're saying that is a rectangle and a rectangle or not?
Because sometimes it well, it says they are all rectangle.
Okay, no problem. Everything is rectangle. Now, I think we're going to the table in order to see that you have the proper equations here.
Okay,
Yeah.
I got a triangle. Like the blue triangle.
No problem. So, what we need to see here is that the direct kinematics and inverse kinematics is performed in the ESP and shown or presented in the computer. So, talk us about that.
Okay, so here, what the HMI shows, it's the reading of the variables that are the data over the motors, right? And the length over the link. So that's how I can reconstruct the way in which it's presented, and in theory, if it worked, it was working. When it's updating, it's showing how the figure moves, and I also can send the data with the sliders as well. This was made over here in my code, I have these functions. For example, this obey motor angle that it's constantly reading, and it's what it sends me in the direct kinematics, right? And here it's the way it moves. This is what moves directly the motors, because we we try to make a closed loop between all the motors, so we can have an acceleration, deceleration ramp, so it has a smoother movement. And here it's handle the inverse kinematics. I deliver here the x and y values, and obviously I have set a height for the pieces, so it reaches that point, it goes down, peaks, goes up, and then with the same inverse kinematic function, it sets a home right here. Here it uses the home, using the values preset inside the microcontroller, right? And it's constantly sending me the angle so I can reconstruct the figure.
Yeah, but the calculations, where do you perform them so that you can get both using the Navier-Hartenberg or your angles for the forward and for the inverse? And where do you call them in your main code? Because you can have something separated but not actually integrated.
Okay, I use this function.
It's just a verify, so it just returns a boolean. I think.
Because here it's calculates.
Go to the definition.
Here it's the calculation. That's where it calculates the. And the directive it reconstructs it by the angle showing the reverse angle and certain error, and it's handled by the function. Sorry, my code is handle the direct movement. That.
And where do you get the operational variables?
Here on update motor angle, that is the one here that is constantly reading the angle, and then it sets the speed, the direction, and the enable, that it's a thing that sets the duty cycle, or sets high, low, or the duty cycle, so I can enter the frequency that I need to the acceleration, deceleration ramp.
Okay. I think I have no more questions.
Me neither. Yeah, I'm really sorry that it couldn't be seen. It has been.
I know it's not an easy project, and I know that we have some problems inside the team. That kind of things happen all the time.
Yeah.
No team is all time.
It is of some use. Here I have also what my partner did in Python. I reconstructed the computer vision. It was actually really helpful, and it was, when we tried to implement it last night, it was like delivering us some points that we could use to track the pieces.
Do you want to see it?
Yeah.
Like on Python? It's like the same.
The same picture. Okay.
Okay, perfect.
So the picture that you took before.
You mean that picture? I cannot extract it and put it.
Yeah, it's like live.
But I can take
It's
another
totally
picture.
different. Okay, it's not integrated in the. Okay. I want to see.
I tried here to make it live with OBS, but OBS also failed. It's I have to retire this computer. It's horrible. It's, I don't know. Okay. Okay. And we took another picture here. It made practically the same.
What are the points?
Um,
How it
it's,
is in Python,
it's a bit different because the algorithms in Python detect not perform different actions. I reconstructed by other methods, but
Okay, which were the methods? No, by heart. It's because, as always I say, if you put a line that you don't understand how it works, how we analyze it, very hard.
no, yes, I can analyze it here. I set my mask. Then
it's like I said before, almost always the code, but how it is translated is not the same.
Yeah.
The reason why it is, can you show the picture? The reason why it is like here is because of the different tones of red that it catches. So it catches that it is another tone of red, and that's why. Because of the
Yeah. See the reflexes. Yeah, but the thing is that as I investigate, I research further, I find these fine contours that it's practically what Beto did.
How does it work? Find controls.
It applies some filters, so it's
Some filter, which filter?
it makes mesh, but well, how to say grayscale. So we only see the color that we want. With the color that we want, it makes like a contour.
How?
of it.
How it makes the contour? That's the question. By heart. By heart. As I said, if you put one line, you don't understand actually what is the method behind. I will penalize because you can
Yeah, yeah.
give me wavelets in,
If I remember-
so I need
No, I know.
I need a very good answer.
Okay. So I said before, it's like make.
No, o sea, es como el método. O sea, if I remember, it was something like some Gaussian filter, and it showed me like the lines. It was practically what we made with the dinosaurs, and that's why it's showing like a lot of points. If I remember correctly, when I did the dinosaurs in MATLAB, I had like these little points all over the place, and you told me that that was not actually the image that was my brain, that was the image. So it makes practically the same, like these points that are like offset.
And that's why it's strange. You have a lot of points in the other figures. Yeah, the square is okay. The other, you have a lot of points. It's difficult. But I think we will lift here. We're going to grade the with that. Okay?
Yeah.
I know it's difficult. We know that the team had some problems, you know. We're going to grade this. Okay?